Okay? Yeah. Okay, so welcome back. We're talking about materials, okay? You've seen all these materials. We're going to talk about them. You have to know how to describe them and sort of decide what they're good for and what they're not good for. So I'm going to talk about each material first, okay? These are the materials you have to know about. So we have wood and modified wood. Modified wood is like particle board or plywood. It's where they've taken scraps of wood and made it into another type of board which we can buy, right? So what are some interesting things about wood? Okay, so here, this is, here, I use this for the Cam and Follower video. This is a modified wood, okay, it's layered. What's good about this? And if you think about it, you probably haven't thought about it much before, but why would I buy wood instead of metal? Well, first of all, it's cheaper. Second of all, I can take this to my house and I can shape it. I made this little thing just with regular tools that I have in my house. Okay, and it wasn't too hard. If this was made out of metal, I don't have the proper tools to shape metal. It takes a lot of work to drill metal, cut it, and so on. You need very specific tools. Wood's easy to shape. It's cheap and it's easy to shape. What are some other reasons you might choose wood? Well, if you're making furniture, you might like the look of the wood and the grain. So instead of painting it with a colored paint, you might paint it with a varnish, which lets you see the grain of the wood. Okay? So, and it's fairly hard. Metals. Why would I use metals? Where did I put my here? So this is a retort stand we use in the lab. It's made of metal. Okay. What are some advantages of metals? Well, disadvantages, it's more expensive. It's harder to make a shape with it. You need very specific tools. Some advantages. Well, it's strong, right? This retort stand has a very thin upright, very, very thin actually, thinner than a pencil, and yet it's really strong. I can hang a lot of weight off this and it will keep its shape. I can make metals for different things, right? So aluminum is a very light metal, a low density, so for airplanes it's very useful. And I can make alloys, mixtures of metals. I can mix them so that they resist corrosion, they won't rust, okay? There are some natural metals, aluminum such, that don't rust either. In reality, actually, just out of interest's sake, all metals actually do rust. The interesting thing is metals like aluminum and stainless steel, they actually get a thin layer of oxides which protects the rest of it. So the layer of rust actually protects it, and it's so thin you barely even see it. Anyway, that's just for fun. So metals and alloys, okay? Then we have ceramics. Why would we use ceramics? Well, you've seen coffee mugs. Turns out, what are some advantages of ceramics? Well, they're very hard. They resist heat really, really well, even better than metals, okay? They do not melt. They're actually made in very, very hot ovens. They're not expensive in general. For example, I have this pot for my plant, very cheap. And you can make them to be beautiful, right? What are some disadvantages of ceramics? Well, they tend to shatter. They're not resilient, right? So if I drop it or I chip them, right now half of my plates and cups and things at home all have chips in them. So that's a disadvantage, okay? And ceramics generally are pretty resistant, okay? So you can find ceramics from thousands of years ago, from the Roman times, the Greek times, because they can be buried and then they'll come out and they're in pretty good shape. Okay, next topic, plastics. There are two types of plastics you need to know about, okay? There are thermoplastics and there are thermosetting plastics. And the key word here, the difference is the word setting, or the part of the word. Okay, thermoplastics are like this container, okay? This container is recyclable. It is generally thermoplastics are softer plastics. You can remelt them and make a new shape with them. They don't resist heat that well, but I mean, that's part of the thing of them being recyclable, is you have to be able to melt them. So they don't withstand heat very well, but still very useful, and they can be recycled. Pretty good stuff. Then you have thermosetting plastics. An example of a thermosetting plastic is Lego, okay? It generally is a harder plastic, okay? If I try and melt this and recycle it, it doesn't work. And the way I remember it is a thermosetting plastic. It is set. You melt it once, you make its shape, and then it's set. You cannot remelt it. What are the advantages? Well, it resists heat better. So I can take this to a higher temperature and it won't melt like the thermoplastic does. It is usually harder, and so that's an advantage. The disadvantage, I can't recycle it. If I try and melt it, it'll burn or catch fire or fizzle. It just doesn't want to get recycled. So these two things have different advantages. One's not better than the other. It just depends what you're using it for. You would have to choose, right? If you need to recycle, you use this. If you need something that's harder and maybe can be in a hotter environment, you'd probably choose a thermosetting plastic. Okay, it is set. Okay, in general, advantages to plastics, well, they're pretty cheap. You can make them fairly hard and rigid. They can still be flexible, so you can make them harder or softer. And the thermoplastics can be recycled. And lastly is composites. And composites is just a general word for any time you mix two materials together, okay? So, for example, you can have Kevlar vests, which have a plastic sort of body with glass-like filaments in the middle. In a sense, concrete that they use for bridges is a composite. It uses the concrete, which is the gray stuff, but it also has the reinforcing bar, the rebar in the middle. Those two things put together make a much better material. Back thousands of years ago.
Carly Carmona, please come to the office. Carly Carmona.
Back thousands of years ago, when traditional tribes would make their huts out of mud and straw, and they would take the wet mud, they'd mix the straw in it, they could make bricks or walls out of it, and the straw would actually make the dried mud much stronger. So those are composites. I'm not going to spend too much time on that because it's a whole wide variety of stuff, and so it's really hard to talk about specifically. Okay. Now that we know what we're talking about, okay, there are some properties of materials, and there's quite a few of them. Don't be intimidated, okay? There are mechanical properties, meaning how materials are affected by physical, stresses, whether they compressed or in tension or deflection or whatever. You have properties as to whether they resist degradation. You have a few other properties. Most of these, you may not.
Nelson Massa, please come to the office. Nelson Massa.
Most of these, you may just not know the proper word for it, okay? So there are specific definitions. So hardness. Hardness is the ability to resist dents, deformations, and scratches. It's really a specific definition. Elasticity means you can stretch it or change its shape and it'll come back to its original shape, okay? Returns to its original shape. Resilience means it resists shattering. So glass is not resilient because it does not resist shattering. If I drop it, it often shatters, right? Fragility. Fragility is the opposite of resilience. Something that's fragile shatters easily. Stiffness. Stiffness keeps its shape. Okay? There are a couple for metals, specifically for metals. Ductility. Ductility is the ability to get stretched. So we can take a ductile metal can be stretched, kind of like melted cheese on a pizza, right? It can be stretched and it doesn't break. It can get stringy. And malleability is a metal, or a malleable metal is a metal that you can flatten with a hydraulic press, like a strong machine, or you can bend it, right? So it can be flattened or bent. Okay, so that gives you an idea of the mechanical properties. Now, just to give an example, I give this example in class a lot. These definitions are very specific. So diamond. Diamond is the hardest material that I believe we know about, okay? So what does that mean? It means diamond is very strong at resisting dents, deformations, and scratches. If you take diamond to glass, it will scratch the glass. If you take glass to diamond, it shouldn't scratch the diamond. Diamond can scratch any other material. The other materials shouldn't be able to scratch diamond, okay? However, somebody may think that you can take a hammer to diamond and it would not get broken. That is wrong. That is a different mechanical property. Diamond is actually quite fragile. It is not resilient. So, true story, a friend of my mother's had a large diamond ring on her pinky finger, and over time she started noticing that the edges of the diamond had little chips on it. So the value of this diamond she lost a lot of money on it, right? If she wanted to get that perfect diamond again to be able to sell it, they would have to grind down the diamond until there were no imperfections. Why? Because diamond is very hard, it resists dents and scratches, but it is not resilient. It can shatter very easily. Okay, so that's why engineers have very specific words for these mechanical properties.